So I received your request for help with this particular question, and it's a good one to get help on because it's a little bit tricky. So this is 12.1 number 23, and of course that's what it is in the study plan. How it shows up in your actual homework, is anybody's guess. But all right, so let's look at this. We have a social worker who wants to determine if the grade distribution of homeschooled children is different in her district than nationally. A National Statistical Center provided her with the data in the first table below. That's over here on the left, so that's the national stuff. Which represent the relative frequency of homeschooled children by grade level. So in other words, only 6.4% of homeschooled children are in kindergarten and so on. She obtains a sample of 25 homeschooled children within her district that yields the data in the second table below. Now the first thing we're doing is, because of low cell counts, we're going to combine the cells into 3 categories. So instead of being K to 3, 4 to 8, 9 to 12. Now I'm not going to do this particular problem. I'm going to do the example, which of course will work very similarly to whatever you have to do. Okay, so let's see here. I don't need to see this part. I just wanted to copy. Oops, I don't want it in StatCrunch. I just want to copy it. Hold on. There we go. Copy. And then I'm going to paste it into Excel because I'm actually going to use Excel. This is a case where I want to use Excel to kind of do some of the mathematical quick work, and then I'll paste it into StatCrunch and do the actual test because, of course, StatCrunch is much better for the test itself. Okay, so what I'm looking for here is combination. So I want to change this table up. So I'm going to make it grade K to 3. And then we want 4 to 8. Now, if I type 4-8, it's going to think it's April, right? So remember how to get around that. You highlight your cells, and we need both of these, so I'm going to highlight both of them. Right-click, Format Cells, and I'm going to make it text. If it shows up in a second. There it is. So I'm going to format them as text. That way, when I type 4-8, it just treats them like text, which is all it is anyway, and 9 to 12. Okay, so that's my grade. Then this is my relative frequency that I want. And then this is frequency. Okay, so in the first column, I'm going to have 8 plus 6, which is 14. In the next column, I'm going to have 4 and 5. That makes 9, and then 2. Now, my total here is 9, 23, 24, 25, and that should be what it, here, let's make sure. I'll just make the computer do it. All right, so I should have 25, and then do I have 25? Yes, I do. Okay, good. That's great. All right, then this sum should be equal to 1. So for this, I want the sum of these 2 cells right here. Yes, I could just add them, but that's too much of a pain. I'll make Excel do it. And then equals this one. As a matter of fact, you could have used those formulas for over here as well, right? And that should also make 1. And if I click and drag, there we go. Great. Okay, so there's my new numbers. So I'm combining together these 2 cells. I'll highlight them. These 2 cells made that one right there. These 2 cells made this one right here. And then the white one makes the white one. All right, cool. So let's double check and make sure that what I just said actually is what they work out. Oh, that's expected. So hold on, let me see. 0.3, oh, right here is where we got it. 0.369, 0.388, 0.243. Let's see. There it is, 0.369, 0.388, 0.243. And the expectations were 14, 9, and 2. That's right there, 14, 9, and 2. So we did that part fine. Oops, I ran back because I wanted to make sure. Okay, so now we need to find all the expected values and all that good stuff. But the good thing is that StatCrunch actually will find a lot of that for us. It won't find the expectations, so we might as well do that part. Expectation is, so let me put it over here, expected frequency. Oh, I don't think we even need this. I think that we're okay. Oh, but I bet you have to type it in, so I'll do it anyway. Expected frequency, because I was going to say to run the test, you actually don't need these numbers because StatCrunch does it for you. But I think you need to type them into the problem itself, so that's okay. You just take 0.369 times your total, which was 25. I can grab it out anywhere. Now give it dollar signs because you don't want that 25 to change. And then you just drag it down. There you go. There's your expected frequencies. And look, it matches up with the example 9.225, 9.7, 6.0. That's exactly what we just got. Okay. So this is, I'm going to change this. This is the observed frequency. Let's change that so we can keep them separate. Okay, so that's what we actually observed in real life. Like, this is the number of homeschooled children she saw in each group, but this is what she was expecting to see in each group. Okay, and then is the grade distribution different? That's running a goodness of fit test. I'm not sure which part of it they need, but let me just show you how to run it. Hold on. I gotta get back to my Excel. There it is. Okay, so all I need is this stuff. The relative frequency, the observed. Oh my goodness, observed frequency. There we go. Okay. And then I'm going to bring up StatCrunch, which I have right here. I'm going to paste that in. Hold on, let me change those widths. Edit, columns, widths, fit. Okay. All right, so let's go to stat. Let's see here. Where is it? Oh, there it is, tables. And, oh no, it's not. I'm sorry. It's goodness of fit. There it is, goodness of fit. Chi-square test. Now, we observed in observed frequency. That's why I changed that one. So observed frequency. The expected is just what we just found. Expected frequency. Actually, I think relative frequency works as well. I believe they both work. And that's it. And then we can click calculate. And there we go. Let's see if that matches what they gave us. Hold on, I gotta find that. Let's see here. There it is. Okay, so right down there, see? Oh, look, p-value is 0.072, and that's what we just found. P-value is 0.072. So I believe in this problem they have you type in the p-value, and then you probably have to make some decision. But let's see, what was our alpha? Alpha is 0.05, right? Since it's 0.05, we would not reject in this particular one, because if you only reject if your p-value is low. You only reject if the probability of what you got is so small that you think something's up, right? But our p-value is 0.07, which is 7%. That's not really that rare, so we do not reject the null hypothesis. I should have stated the null hypothesis in goodness of fit is basically that the distribution that you have matches what you thought it was going to be, what the expectation was. So in this case, it basically did match, right? So we did not reject the null hypothesis, which is basically the same. The alternative to that is that they're different, right? That what you got in real life is fundamentally different, significantly different, I should say, from what we expected. We would do that if the p-value was less than the alpha, but it isn't in this case, right? So we're going to say that we don't have enough evidence to prove that they're different. All right, I hope that helps with that one.